So now to find out the support reactions, that is reaction HB, reaction VB. So these are two reactions for the hinge support, and reaction RB, it is for the roller support. Okay. So we need to use the conditions of equilibrium. So conditions of equilibrium, we have three conditions. First is summation Fx, it is equal to 0. Second condition is summation Fy is equal to 0. And third is summation of moment is equal to 0. Okay. So when we use these conditions of equilibrium for summation Fx, summation Fy, or summation of moment, okay, first step is resolve the forces which are inclined to the x and y axis. Okay, so if you observe this complete free body diagram, then there is only one force which is reaction RC, that is inclined to x axis. Okay, so at this point, resolve the reaction RC. So suppose this is the reference line, that is your x axis. Okay, so this angle is 60 degree, so this angle will be 60 degree. Okay, so we can show the components. So this is the x component. Okay, and at point C, this is the vertical component, that is the y component. So x component here, this is RC cos 60, because this is adjacent side, this angle is 60 degree, and this component will be opposite, so it is RC sine 60. Okay, just observe the direction of the net force. So net reaction RC is acting towards the point C, so your components will be towards the point C, that is RC cos 60 and RC sine 60. So now you can use the summation Fx 0. So for summation Fx, it is equal to 0. So write summation Fx. So first is HB, positive x direction. Then second force in the x direction, it is RC cos 60. So it is minus RC cos 60. It is equal to 0. Okay. So in the single equation, we have two unknowns. Okay. So we cannot solve this. So just give this equation 1. Then you can use the summation Fy. It is equal to 0. Okay. For summation Fy, first is 10 Newton in the negative y direction. So minus 10. Next is 50. So minus 50. Then minus 30. Okay. Then vertical is VB, vertical reaction. So plus VB. Then next is RC sine 60. So this is plus RC sine 60. Okay. It is equal to 0. So from this, we can write the equation as VB plus RC sine 60. It is equal to, add all these terms. So minus 50, minus 30, minus 80, and minus 10, minus 90. On the right side, it is the positive, so plus 90. Okay. So this is equation 2. And then use the third equation, summation of moment. It is equal to 0. Okay. So this summation of moment we can take at any point of the system. Okay. But select such a point where the maximum unknown we can cancel out. Okay. And at least one unknown we can calculate. So if I take the moment about the point B, so if I select the point B as a moment point, then VB and HB moment will be 0. So two unknowns we can cancel out, and we can find out the one unknown, that is the reaction RC. Okay. So we will write this moment equation as summation of moment by all the forces about point B, it is equal to 0. Okay. So now take the moment by all the forces. So you can start from the 10 Newton. For 10 Newton, this is the line of action and this is the perpendicular distance. So this is 0.5, this is also 0.5. So 0.5 into 10, so moment will be 10 into 0.5. Okay, and this moment will be anti-clockwise direction about point B, that is positive. Then second moment by VB, it is 0. Moment by HB is also 0 because both the forces, they are passing from the point B. So perpendicular distance is 0. Okay. Next is 50 Newton. So 50 into perpendicular distance is 2 meter. Okay. And that moment is clockwise. So it is minus. Next is 30 Newton into perpendicular distance. It is 1 plus 1, that is 2 meter. And again that moment is clockwise, so it is negative. Next is RC sine 60 and RC cos 60. Okay. For RC cos 60, the line of action, it is passing through the point B. So if I extend this line of action, it will pass through this point. Okay. So moment will be directly 0 because there is no perpendicular distance. We can only take the moment by RC sine 60. So RC sine 60 into distance is from point B to C, it is the perpendicular distance. So it is 6, 3 plus 1, 4 plus 2. So this is 6 meter. And that moment is anti-clockwise. So it is positive. It is equal to 0. Okay. So from this equation, you can find out the reaction RC because one equation and one unknown. So get the value of reaction RC. Okay. So you can give the answer in the chat box. What is the reaction RC? So once you get the value of reaction RC, put this RC in the equation 2, calculate the VB, okay, and put the value in equation 1 and calculate the reaction HB. Okay. So in this way, you can find out the reaction HB, reaction VB, and reaction RC. Yes, try to solve this. So reaction RC, it is equal to 29.8297 Newton. Okay. So put this value of reaction RC in the equation 2 and get the value of reaction VB. Okay, so you can check the answer. Reaction RC is 29.829. It is acting at angle theta, that is 60 degree. Reaction VB is 64.18 Newton. Okay, it is exactly vertical because we get the answer positive. So it is along positive y direction. Then reaction HB is plus 14.91. So answer is positive. That means at point B, HB direction is correct. Okay, our assumed direction is correct. HB is acting on the positive X side. Okay, so these are the support reactions for the given beam ABCD.